stuck or something, or if you're not able to follow. But here's the quiz. Do you, you're free to open that on your Chromebooks and just follow along. Um, I believe everyone got question one right, and you'll have to answer now. You can unmute yourselves or to answer because I cannot see you anymore. I'm on the actual quiz sheet. So, was there any problem with question number one? Yes or no?
No.
No. Okay. Again, you'll have to answer because I can't see anyone here. Um, so question one wasn't a problem. For question number two, um, most of you got it right, but there were some problems, especially with part number C. So let's see here. Let's go here. Question one, there wasn't any problem. This is going to be quiz. Oop. Right. So question number one, question number two. If you switch back here, um, for this graph shown, is the car direction movement always the same? The answer was no. Um, then what is the total distance traveled by the car? Remember, for distance, we were moving, well, it was 30 kilometers. So this is kilometers. Time is in hours. So 9, 10, 11, 12, 13, and 14. These are, um, so 900 hours, 1000 hours, 1100, 1200, 1300, and so forth. Um, so during this entire journey, you had covered a total distance of 120 kilometers. What is the total displacement of the car? The answer to that was 0 kilometers. Why? Because remember, displacement was the net change in position. So when you're moving from in whichever direction this is, so A, B, and C, that is 60 kilometers in one direction, and D is 60 kilometers in the opposite direction. So the total distance or the total displacement of the car was 0 kilometers. And for what time interval is a car stationary? You had to write the answer 11 and 12, or 11 to 12. No, that was the correct answer. Um, any questions with this so far? No? I'm assuming not then. So for question number E, or part E, question two, part E, what you had was, well, you had to find the speed of the car, right? Now, what is speed given as? Speed as distance, or change in distance, divided by time, or delta x by delta t. And some of you did convert it to meters per second, others did not. I didn't specify, so just doing it in kilometers per hour would have worked too. So for journey A, it would have been simply 30 kilometers minus 0 divided by 11 minus 9. So it would have been, speed would have been 30 minus 0 divided by 11 minus 9, and that would give you 15 kilometers per hour, and that was the correct answer. For journey B, it was 0 because the car was stationary during that time, right? So there's no change in distance that occurred, so the speed is 0, although that you had covered some time. For part C now, you had covered 60 kilometers or an additional 30 kilometers. So you moved from 30 kilometers here to 60 kilometers in a time span of 30 minutes or zero point 0.5 hours. So journey C then is 60 minus 30 and 12.5 minus 12, or 30 by 0.5. and that would give you 60 kilometers per hour, right? And then for journey D, remember the question's asking you for what? The velocity of the car for journey A, B, C, and D. So velocity, you need to account for the direction as well. So in this case, you're moving in the opposite direction. So you've got 0 minus 60, and then the time taken was 14 and 12.5. So 14 minus 12.5, or 60 divided by 1.5, and the answer was, sorry, negative 60, and the answer was negative 40 kilometers per hour. And finally, for part F, it's asking you for the overall velocity, right? And when we're talking about velocity, velocity is displacement divided by time, and your total displacement is 0 kilometers. I believe this was a total of 5 hours, so it doesn't really matter. Um, it's still going to be 0 kilometers per hour. Any questions with this? Again, you'll have to unmute yourself, say something, and then I can move on.
I think we're good.
Okay. What about question number 3? Most of you had problems with part C and part D, and some even had problems with part B as well. So let's start with question number 3 then. Question number 3, part A, was to do a free body diagram. Now, a free body diagram is what? You have to represent the entire system by a point mass or a single dot. That's what we would do for the lawnmower. Now, the question specified to you that, well, there's a person who's pushing a 98.1 Newton lawnmower with a force of 25 newtons at an angle of 15 degrees to the horizontal. So you've got a 25 Newton force applied here, and the weight of the lawnmower is given to you, and that's 98.1 newtons. The other two forces that you could have had added to this as well, 15 degrees, so 25 cosine 15, and then there would have been an additional support here, so F normal or F support, and then since this is acting this way, there would have been some sort of frictional force here, or resistive force. Now all of this would have gotten you 3 points here. If you did just the dot and the force diagrams and you forgot to label which force is which, you only got a single point. And then depending on how many forces that you plotted, I gave you points accordingly. I'll try to scan the solution in for all of you and then email it to you individually. For part B, then the question was asking you, well, what is the mass of the lawnmower? Now, remember, weight is what? Weight is equal to mg. Weight has been given to you, 98.1 newtons. M and G is 9.81. So, in other words, 10 kilograms was the mass of the lawnmower. Any questions with this? Nope. Okay. Again, you have to stop me if I'm going too quickly or something's not making sense. Um, so you'll have to unmute yourself and then tell me. For part C, what is the work done by the person? Now, the distance that the person moved it by was 50 meters specified in the question. So you've got work is equal to force times the distance. But the condition here was that the force must be parallel to the direction to the movement direction. So in this case, if we switch back to our free body diagram right here, you've got a force that's being applied at an angle. So you needed to find the component of the force. So we'll have to use Fx times the distance. And that was given as 25 cosine of 15 times the actual distance that the object moved through. And the answer to this was 1207.41 joules. And most of you just multiplied 25 times 50. Any questions with this? No? Okay. For part D, then, if the lawnmower is moving with a constant speed, what is the frictional force? Now, recall what we talked about in our frictional lab. If the object's moving at a constant speed, that means there's no net acceleration acting on the object. That means that your force or net force is going to be equal to 0 newtons. What that means is that the forces acting on the object are in balance. If your F net equals to 0 newtons, then your forward force is equal to your frictional force. So in this case, if you're moving at a constant speed, that means your A net is equal to 0 meters per second squared. And since F is equal to ma, your F net is going to be equal to 0 newtons as well. And that means your F forward is equal to F friction. And that's going to be equal to 25 cosine 15. And that's your frictional force, which equals to, what is 25 cosine 15? 24.15 newtons. So that was the answer to part D. And then finally for part E, it was asking you to find the kinetic friction coefficient. And the kinetic friction coefficient is, well, when the object's moving at a constant velocity. So you've got your force being applied divided by the weight of the object. In this case, again, the force being applied in the horizontal direction, again, is 25 cosine 15 divided by the weight, which was 98.1. So the answer to this was around 0.25. And then again, since this is a force, the numerator is a force as well. So the units here are newtons, and the units for weight are newtons. These would cancel out, and this is a dimensionless quantity. Right? Any questions so far? No questions? Right, okay. Please speak up because I can't switch back to this tab again because it will probably crash the Chromebook. Because I'm recording on it as well. So if there are no questions, then let's move on to question number 4. Question number 4 then is talking about a 45 kilogram Olympic diver dives off a 5 meter diving board from rest for an Olympic event. With what velocity will she impact the water with? So you've got your mass given to you, 45 kilograms. And then you've got your height as well, which is 5 meters. Part A is asking you for the velocity of the diver just before impact. So there are two methods that you can do it with. Once you use the free fall equations or equations of motion. So in this case, since you know the height, you know the acceleration, which is going to be 9.81 meters per second square for part A only, right? We could use either, well, the last equation or the third equation because we're looking for the velocity, plus 2a delta x. So Vf squared is equal to 0 squared plus 2 times 9.81 times 5, or Vf is equal to radical, and 2 times 9.81 times 5 is equal to 98.1, and that is equal to 9.9 meters per second. There was another way to solve it with, and that was using the conservation of energy principle. Now, when the diver is right at the top of the diving board, she's got she's got potential energy. Potential energy was due to the height of the object above ground level. So you've got potential energy is equal to, or it will convert into kinetic energy, or half mv squared. So potential energy before the diver impacts the water, it's going to convert into kinetic energy, and that's going to be equal to, well, kinetic energy, and then you can solve this equation. So again, if you were to solve it, you would get gh is equal to half v squared. You can rearrange it and you would get 2gh is equal to v squared, or v is equal to radical 2gh. And if you substitute the values in, you get 9.81 times 5. And this is exactly the same scenario you were in here. So you're going to get 9.90 meters per second. So there were two ways to solve it. Both were equally, they were both correct. Now, part B is asking you for, well, if the force exerted by the water on the diver is 800 newtons, how deep did she dive? Right? Now, again, we had done this before, and there are two ways to do it. Once, again, you could either do it with free fall equations, or you could do it with the work energy thing. So let's start with the free fall part. Now, since it's talking about that the water is exerting a force on it, so, and it's exerting a force in the opposite direction to the diver's movement. So you've got a force which is negative 800 newtons. So forces again is equal to ma. So you can find the acceleration through here. So it would be negative 800 divided by 45, and that would give you an acceleration of negative 17.78 meters per second squared, right? And then you could use the equations of motion. So we are looking for how deep did she dive in this question right here. So we're looking for the distance. You can have delta x is equal to vi delta t plus half a delta t squared. Well, we cannot use this equation because we don't know what the time is. Or we could use vf squared is equal to vi squared plus 2a delta x. Now, in this case, our initial velocity here, our final velocity is 0 squared, is equal to, well, the velocity that we were moving with, 9.9 squared, plus 2 negative 17.78 delta x, right? Or if you rearrange it, you're going to get delta x is equal to 9.9 squared plus divided by 2 times 17.78, and you should get an answer of 2.76 meters, right? The other way that you could have done it was using your work done and energy formulation. Now, you had done this question before in the case of the bullet penetrating the tree trunk in your homework assignment. So, what is this going to be? Work done is equal to the person was or the diver is moving with kinetic energy. And so you've got force times the distance times half mv squared. And then you've got 800 times the distance, half mass of the diver is 45 times 9.9 squared. And if you were to rearrange everything, you should get the same answer. So let's just do that 2.76 meters. So any method that you worked it with would have got you the correct answer. The last part of the question was asking you for, well, how long did it take for her to come to a complete stop in water? So part C would be then you're looking for the time. So let's use one of the equations of motion. Vf is equal to Vi plus A delta t, right? We found the acceleration in the previous page, or that is negative 17.78. We know that our final velocity was 0. Our initial velocity is 9.9 plus negative 17.78 times delta t. So delta t would be simply 9.9 divided by 17.78, or I believe the answer was 0.56 seconds. Questions? Nope. Okay. And then the last question then is question number 5. So you've got to maintain social distancing. So it's this was a projectile motion question. The trick here was that there's a height added to it. So let's do question number 5 then. So all we know from the question is that you've got the person builds a catapult which is able to launch candies from his door to the children. Then where should he place the receiving marker such that the candies are caught by the children? The launch height, velocity, and angle are 0.75 meters, 10 meters per second, and 30 degrees. So we know our velocity, our initial launch velocity, which is 10 meters per second. We know our angle, launch angle, which is 30 degrees. And then we know our height or elevation above, or the difference between our launch height and receiving end. So now if you go back through your projectile motion lab notes where we had written down the steps that you need to follow a projectile motion question, what was the first step that you did? Step 1 was, well, you find the velocity components of your velocity. So we're looking for Vix and we're looking for Viy. So if this is your little free body diagram, you've got 30 degrees here at 10 meters per second, and it's going to arc, follow this little trajectory here, and this should be this little marker here. Now this height was 0.75 meters, and we're essentially looking for, well, this distance, delta x. Now, first step was to find everything here. So Vix is going to be cosine of 30. So Vi cosine 30 is going to give you that answer. And Vi sine of 30 is going to give you the velocity in the vertical direction. So if you do that quickly, 10 cosine 30 is going to be equal to 8.66 meters per second. And then VIY is going to be 10 sine of 30, and I believe this was equal to 5 meters per second. Right, so that's step one done. And then in order to find the distance, delta x, remember delta x, let's just erase step two for now. Delta x was dictated by what? Delta x is given by VIX delta t total. Now, delta t total, if you recall, was a combination of two things. Delta t total is delta t up plus delta t down. And, well, then you could solve for delta t up and delta t down. Now, delta t up was given by, let me pull up my formula sheet here. Let's see here. Anyone recall what was the formula for delta t up? Right. So you've got two equations. One is that VIY is equal to G delta T. These are from the up direction equations, projectile equations. So we've got one equation that is this, and the second one is VIY squared is equal to 2G delta Y. Right, since we're looking for time, we'll use this equation right here. So step two was to find delta T up. Delta T up is then given by VIY divided by G, or VIY was 5 meters per second divided by 9.81, and you would get somewhere point 0.51 seconds for the answer. Now, the next part was to, well, actually find what delta t down is. But in order to find delta t down, you first need to find, well, what is the total distance that you're going to travel. So step three was, from your notes, step three is to find delta y up, which is given by this little equation that you just saw here, 2g delta y, or VIY squared divided by 2g, or 5 squared divided by 2 times 9.81, and that's equal to 25 divided by 19.62, and that would give you 1.27 meters. Now, step four was to find delta y down, which is equal to delta y up plus any height difference. Now, in this case, since the receiving end is lower than the launch height, you would add them, and that would be 1.27 plus 0.75, our height difference, and that would become, or that would be equal to 2.02 meters. Once you found all of this, now you can solve for delta t down. So step five then becomes delta t down. Delta t down was given by, well, or this is the formula that we can use here. Delta y down is equal to half g delta t down squared. So delta t down would then become 2 delta y down divided by g under the radical, or 2 times 2.02 divided by 9.81 under the radical, and that should give you an answer of 0.64 seconds. Step 6 was to find the total time. That delta t total then is delta t up plus delta t down, or 0.51 plus 0.64, and that's equal to 1.15 seconds. And finally, delta x is equal to VIX times delta t total. And VIX, if you recall, was 8.66 meters per second times your delta t total, which is 1.15. And that should give you an answer of 9.98 meters. And some of you wrote close to 10 meters, and that was correct too. And I believe that was the last question on the quiz. Let me stop recording this.